Museums hold thousands of objects.
What exhibitions are on now?
Show artworks under €8,000. Our tool is hosted in app, which lets us launch our services and collect telemetry across the whole system. We use the AGUI protocol to run the workflow as an agent in one service for scalability, and the Blazor UI in a separate service. Now let's walk through the workflow from start to finish. First, we upload the schema in our clean, Fluent UI-styled application. Next, we upload supporting facts and a few examples. Then, we upload the security policy, where we can configure row-level security, column-level security, and other rules like role-based masking or access limits. And now, let's jump into the workflow. The full end-to-end workflow can look overcomplicated, so I split it into a couple of smaller parts. First, I'll show the concurrent retrieval workflow. The Supervisor agent orchestrates 3 RAG agents, each connected to its own vector index. They retrieve 3 context packs: schema, SQL examples, and security rules. And the Supervisor aggregates the outputs for later steps. Each retrieval returns a structured result, JSON-like, typically content, merged text for prompting, plus source_chunks, passages with metadata like doc ID and similarity score. Here you can see the Supervisor working with those RAG agents and their retrieval tools. The Supervisor generates a specialized retrieval query per tool, one optimized for schema, one for examples, and one for security policies. In the workflow event, we capture all tool outputs and store them as an aggregated object. For example, schema_context, examples_context, and security_context, each containing content plus source_chunks. That aggregated context is then fed into the next workflow, the SQL loop. Workflow. The SQL generator uses schema_context and examples_context to produce a candidate SQL query, returned as a structured output like ESQL notes EOS. It then sends the SQL to the SQL validator. The validator enforces the security_context retrieved from the vector index and calls 2 tools: static SQL code analysis and a test execution. Those tools return a machine-readable validation results. For example, on status, pass to fail, issues, error, execution, preview, orky. If validation fails, the workflow increments a retry counter via the track, attempt executor step, and loops back to the generator with the validation feedback. If max_retries is reached, the workflow fails. If validation passes, the workflow executes the SQL and returns the approved SQL plus the table result, rows/columns. Finally, the Supervisor receives final_SQL, result_table serialized in tune format to spend less token and uses it to generate the answer shown to the user. Here's what our initial plan looked like for the hackathon and where we want to take this next. We plan to move all tools behind MCP servers and use the A2A protocol to host agents in separate services for better scalability. On top of that, we'd have a single gateway service that discovers agents via an agent card and dynamically adds them into the workflow. We also had a more ambitious extension: spin up an Azure container app running GitHub Copilot CLI. So based on the SQL results, it could automatically generate an HTML report, or even a small website, summarizing the findings. And finally, we wanted to implement the same workflow in the Microsoft 365 Agent SDK. So Microsoft 365 could act as a client, and we could plug into the wider M365 agent ecosystem. Time was limited during the hackathon, so we focused on delivering the core end-to-end flow you've just seen. But this is the roadmap we're aiming for next. From schema to insight in seconds,